All right. So we're officially getting started here. This is the first in-person JaxNode meeting in over a year. We're very excited to be doing this. So just to kind of update everybody on what's been happening with the user group is that since March of last year, we've been doing virtual meetings, and we've been using Zoom to do that. And one of the things that's nice about Zoom is that you can record the meetings like what we're doing right now, and then we've been able to repost the video of the meetings and stuff on YouTube. So right now the plan is to continue doing the Zoom meetings, and but we're now officially having in-person meetings. So we're officially meeting in an actual meeting place. And so we're really happy about that. So with that, let me go ahead and pull up my slides here if I can find them. All right. So let me see if I can make this a presentation. Present. All right. Can everybody see it okay? Yes. All right, good. So what I'll do is, like, if people have problems reading any of the text on my screen or whatever, I'll try to blow it up. But we are officially starting now. All right. All right. So I picked this topic mainly because we did a couple of presentations earlier in the year where we were doing kind of like stock analysis, and we were doing stuff where you kind of have to record data in real time. And so for the examples and stuff I used a database called TimescaleDB. And TimescaleDB essentially it's an extension that runs on top of Postgres. And so I figured that deserved to be its own topic by itself, and so that's why we're doing this. We're doing this tonight.
You want to make it full screen?
Yeah, let me make that full screen. Is that better? All right. So on that note, now that we're actually meeting in person again, one of the things that I'm always trying to do is trying to find speakers for upcoming topics. So if you're interested in doing a presentation, please let me know. It doesn't have to be JavaScript specific. Tonight's presentation is a little bit, off topic in the sense that it's a technology I work with Node, but it's something that's completely its own thing, which is really covers kind of like the persistent side of applications. So if you're interested in giving me a presentation, let me know, and we can get that set up. So a little about me. My name is David Fecky. I have a blog you can read. It's feck.io/blog. And I also have a channel called the Polyglot Engineer channel. And so when I repost the video for this, I'll do it on that channel as well as our JaxNode YouTube channel. All the code and stuff like that I present on, I usually put up either onto my own personal GitHub page, or I'll do it onto the JaxNode user group has its own GitHub page as well. And I also I use Twitter to repost like different articles and posts that I found on Node.js and just software engineering topics in general that I usually post to these the two following Twitter addresses down here below. So either JaxNode or the Polyglot Engine 1 are the two handles that I use. So let's talk real quickly about databases. Hopefully this is something that everybody's had a chance to use. And there's a number of different types of databases that we might have worked with in the past. So I've been doing this for a little over 20 years. And at the very beginning of my career, I started with a database product. It was called SQL Server 6.5. And
You missed one.
I'm missing one?
The flat file storage.
Well, so I will get into that in a second. So I mean, there's there's also a whole slew of new databases that have come out. They're very popular. And those types of databases are also, I'll mention those in a future slide, but those typically are mentioned, flat files are typically thought of as like column databases. And so, for instance, like most of the cloud providers now have some version of that, where they have a kind of like a flat file style of database that they use, but they're usually very highly scalable. There's, I'm sure people here have used or might have used MongoDB. MongoDB is considered a document database. Those are also very popular. There's graph databases. And so, for instance, like Facebook is an example. They built their own graph database as an example. And then there's also event stores as an example. So like Kafka is an example of something that's an event store. And so one of the things.
One question about Kafka and event store database.
Yeah.
I thought Kafka was just a message queuing thing. Is that not?
Well, that's primarily what it is. So with Kafka, you can create topics, and then you can subscribe. You can have a service that subscribes to a topic, or you can publish to a topic. But the idea there is that instead of writing something out to a table, you basically just fire off an event, and then you have a service that listens for that event and handles it, whatever way it's going to handle it. Maybe it's going to store it into some type of database. Maybe it's going to do some type of processing on it. Maybe it's going to send an email. There's all kinds of things you can do with that event. So that's primarily my understanding of Kafka. I've never used Kafka personally, but it's my understanding of how it's used.
How do you see that as a data store? Data in motion, I guess, going from one end to the other end. But it's very hard for me, at least, with my limited imagination, to see that as a data store.
My understanding is that it keeps a log, or you can have it keep a log, and then you can, and this actually feeds into what we're talking about tonight with TimescaleDB, is that when you're working with like highly scalable, like highly transactional type data, my understanding is Kafka is like perfect for that. And so one of the reasons why a lot of these, what are called NoSQL databases, are not only SQL, is what some people have referred to NoSQL databases as. One of the reasons why those have become popular is because they've handled these edge cases that you couldn't handle with a normal relational database. So the reality is that in modern enterprises and stuff like that, we're probably using a combination of these different databases, right? So you may, like I know, for instance, Florida Blue is an example. They have like Oracle. They have systems that use Oracle databases and stuff like that, but they also use MongoDB. So and in some cases, you'll have applications that use multiple different data stores depending on what you're doing. So that's one of the points I wanted to try to bring up with this slide is that the modern enterprise and stuff like that may be using a bunch of these different types of databases. So with relational databases or SQL databases, there's pluses and minuses to using those typically. So generally, this has been my experience with SQL Server is that you start to wind up with a place where in your applications where you can have a single point of failure. So for instance, like with most web applications, it's pretty easy to scale those out horizontally. So for instance, if you get a lot more traffic and you want to start scaling it out, it's usually pretty easy. You can just spin up new servers and stuff like that. But with databases, typically they write to a single file storage unit. And so because of that, that's limited like how easy it is to horizontally scale one of those types of databases. So that's been one of the, I guess, ribs on relational databases is they're difficult to scale. Data is usually broken up into tables. And they've also typically, most of them haven't had really good JSON support, but I think a lot of times now we wind up with, people wind up storing JSON as like a text blob or something like that in some of these databases. Some of the pluses are, you can use standard SQL. So a lot of these, SQL alternatives have like a single like query language that you can use. So for instance, if you use GraphQL as an example, it has its own query language. It's not SQL. But a lot of times they've come up with their own query languages that they're using. There's lots of people. I mean, SQL's been around for four or 5 decades now. So there's a lot of people that have experience using SQL databases. That's definitely a plus. They also tend to be very efficient with data space. And so one of the knocks against SQL, like for instance, one of the things I've heard from my friends that are real Mongo aficionados is like, well, disk space is cheap, and it's like you can replicate data inside of a single document. It's not a big deal, because disk space is cheap. But if you're building like a scalable application that you want to deploy to, let's say, the cloud, like AWS as an example, it's like you pay for everything. You pay for your bandwidth, you pay for disk storage, or S3 storage, you pay for the CPU time and stuff like that. And so it behooves you to try to architect your applications to be as efficient as possible. So that's one of the things that's also nice about SQL. And then of course you also have ACID, which I'll get into in a second. So SQL, the language, it's a set-based language. It's a kind of a proprietary thing, but there's a standard that's used for SQL. And the joke I usually have with my colleagues and stuff like that, well, how hard could it be? Because there's only 4 commands, select, insert, update, and delete. But the truth is there's a lot you can do with those 4 commands. You also have the capability of joining tables together. So if you need to kind of like construct, a data model that, has lots of has a or is a type of relationships and stuff like that, you can do that pretty easily with SQL. You can manipulate many rows at the same time with a single SQL statement. So it's very powerful. You also have the ability in most database systems to create indexes and views and store procedures. So we'll get into that here as well. So there's lots of vendors for working with SQL databases. Obviously, Oracle is the big bad daddy. I think they had the first relational database on the market. There's IBM DB2, Microsoft SQL Server, which now runs on Linux. There's SQLite if you need to run a kind of like a single instance, let's say on like a mobile device or even a web browser. There's MySQL and MariaDB, which is a derivative of MySQL. Sybase, Postgres TimescaleDB, which we're talking about tonight. And then I put the last point on my slide here. I mentioned AWS RDS. And so I don't have a whole lot of experience working with a lot of the different, I've worked with Azure a little bit, and I've worked with AWS. But both of those have, real-time, data services that you can use. And you can use, all kinds of different things. So I believe that one of the RDS types that's supported with AWS is Postgres.
Yep. Postgres, AWS Aurora Cluster will run you $150 a day if you're not paying attention.
Oh, yeah. Excuse me.
We found the hard way.
Oh, yeah. So this slide I called One Database to Rule Them All. Picture Gollum there. And it's one of the reasons why I kind of picked the topic tonight is because Postgres kind of solves or fills the void of some of the things that you really kind of required a NoSQL database you can do now with Postgres. So Postgres is not new. It's been around for a long time. I think the original project started in 1985, and I think the first open source version of it was available in 1995. It's open source. It's ACID compliant. You can also store JSON documents with it, and it has some features in there where it make it easier to kind of like index and query data from JSON documents. There's also PostGIS, which allows you to store location type location type data. And then it also supports extensions. So TimescaleDB is an extension of Postgres. And this is a solution that's meant to be for high volume inserts and selects. So one of the things that it's built around is this idea of, we're talking about Kafka earlier, and one of the things that Kafka is really good at is if you're dealing with highly transactional type of data that's coming through your application, well, TimescaleDB is meant to be that type of system. So a lot of financial firms, a lot of like Wall Street firms, as an example, use TimescaleDB specifically for this reason, because they can just push a ton of data through the database at one time. And so, the performance should be along the same lines as, the NoSQL type of competition. And the way they're able to do this, they do this through something called hypertables. And hypertables actually work with chunks of data. And I'll explain how that works here in a second. So there are a lot of query tools that you can use if you're using Postgres. So I've just mentioned a couple here tonight. I'm actually going to be using Table Plus. And you can go online and you can probably find, 30 more clients you can use if you just want to query Postgres and stuff like that. I'm using Table Plus, but you can use pgadmin if that floats your boat. So let's talk a little bit about ACID and why that's important. So ACID stands for atomicity, consistency, isolation, and durability. I probably butchered the first one there. But the idea there is that, if you are essentially going to be, inserting a piece of data or updating a piece of data inside of the database, if one part of that fails, it's basically inside of a transaction and they can back out of the whole thing. So you don't have to worry about, committing that or worry about part of your transaction being committed when you don't want it to be. Consistency basically means that the data has to be valid. Isolation means that your transactions can't basically interfere with each other. And the idea there is that if you have two people there, let's say trying to update the same row on a table, as an example, it's going to ensure that they're not both doing it at the same time. They can only do it one at a time. And then durability is basically just making sure that you don't ever lose your data. That'd be bad, and I've actually seen and experienced that where there's been data loss. That's not good. You don't want to have that. So some of you, this is probably old hat. Others, this may be brand new, but this is a SQL statement, and the way that select statement works is that you basically say select whatever columns that you want to grab. And then you'd say from the table you want to grab those columns from. And then you can specify a where clause where you can say, okay, I only want to basically pull back the rows that match this predicate, as an example. So here I've done a select star from users where clue is greater than 0, results equals 0. So that's a joke. But this is typically what you'll see with a SQL query. You'll typically, whoops. Oh, you all right? Whoa. Sorry about that. It's okay. First dog I've met that's a klutz. So, anyways, so typically the way that you would write something like this out is you'd say select, I've got an ID column, first name column, last name column, maybe an age column. In this case, I'm doing it from a person table. And then I want to do it from any person where their age is greater than 32, greater than or equal to 32. And so you can use that type of logic in your predicates to pull back just those records that you need. And we also have the capability of joining tables together. So for instance, let's say I have that data that I have in my person table, but I also want to join it up to, let's say, data that's in the user table. I can do that pretty easily by just specifying a join between those two tables. Here I'm actually using an alias. So I have a P for the person and then a T for the user table. And then
David, you have an error. There is no U. You have u.username.
U.username? That's my bad. I'll fix that.
Just kidding.
Fix that in post. But yeah, I think I changed the name of the user table from U to T there. But that would fail. if you try to run that in a query running program. So in this case, let's say I did have the U after the user table. This is a left join. And this is one of the things I think is beautiful about SQL is, let's say you're joining up these two tables, you want to pull back these rows, but let's say there's no matching rows for some of those records in the user table. Well, by using a left join, now what I can do is I can say, well, I want the person to be the table of precedence. And then if there are records that join up to the user table, then I'll pull those back as those columns. But if they're not, then those come back as nulls. So if we look at the example down here below, in this case, this one record right here with Bob McKenzie, there was a joining record for the user table, but for these other two records there wasn't, and so it just pulls back null for the username with that example. So if we didn't have the left join in this join, what would happen is we just would pull back one record for Bob McKenzie. So that's kind of the important thing there about joins. But you know, there's a software engineer that I followed pretty early on in my career named Hal Helms, and he had this joke about SQL databases. Like if you're taking your car and trying to park it into a database instead of a garage at night, you'd have to take all the doors off and put them into one drawer. You have to take all the wheels off, put them in another drawer, and stuff like that. And then when you combine them all together, when you want to take it out at the end of the day or in the morning, stuff like that, you kind of have to reassemble. And that's essentially what you're doing with SQL, is you're taking all this data and you're putting it into very specific places, and then you're pulling it back out when you need it. So data definition language, basically, these are the types of SQL statements that you use for doing things like creating tables, creating indexes, creating views, materialized views, and also store procedures. And the thing that's interesting about DDF is that it's different from, let's say, like a select statement or update statement. Those all make up what's part of the SQL standard. But one of the things you'll find is when you start working with different database vendors is that they all have their own derivatives of SQL they use for the DDL portion of their languages. And so what works for Postgres may not work for, let's say, SQL Server as an example. So this is an example of how you create a table inside of Postgres. So for instance, if you want to have a record that's like an ID record, you can specify serial. And what that'll do is that will actually create an integer value that increments every single time you go to create a new record in that table. And they have all these different data types here. So for instance, like I have a symbol and a name data type, which are just using text. Text in Postgres is essentially it's like a type of varchar, but something that's not limited to any specific size. And then also I have a Boolean here. So this is an example of like how some of these database systems differ. Is if I was using SQL Server, I was trying to do this in SQL Server as an example. SQL Server doesn't have a Boolean, they have a bit value, and which you can set either to 0 to 1. But in Postgres, this is a little bit more user-friendly. They actually use a Boolean, and you can say true or false when you're setting that value. You also have the capability of creating indexes as well. Indexes are important if you want to be able to join up on a specific column or be able to search with where clause on a specific column. They help improve the performance of the database when you're doing those types of queries. You can also create views. This is an example of a view that you can do inside of Postgres, where you can kind of define a view and specify, in this case, they just want to pull back comedies. And you could do like a select star on comedies, and it works just like if you're doing a select star on films, but you don't have to specify comedy as a kind in the where clause. So that's kind of a simple example of how you could use a view. Typically, a lot of times, the reason why people use views is that they'll do it for security reasons. Like they'll define like a specific view into a table that they want a certain portion of the users to be able to see. but they will hide certain columns and stuff they don't want to make available, and that can be controlled through access controls. But that's an example of a view.
I think the views provides the fast access to the data as well.
So yeah, so in Postgres and also Oracle, they have this concept of what are called materialized views.
Yes.
And that's one of the things that materialized views are great at. If you need to, let's say, have a snapshot of the data and stuff like that that may not ordinarily query very quickly, but you need to be able to pull that up. It's almost like a cache or something like that that you can use that's maintainable. And so I haven't worked with Microsoft SQL Server in about 5 years. So I don't know if they have materialized views. I remember that was one of the issues. Like, man, I really wish I had materialized views in SQL. They may have it now, I don't know. But back when I was using it, we didn't have it. This is an example of a store procedure. And so one of the things that's interesting about Postgres is that one of the things you'll see here is like they have a language specification. And this is actually starts off with the PL, PGS, QL. And with the PL, basically, that's the same as, or basically it's supposed to be a reference to PL SQL, which is the specific flavor of SQL that's used with Oracle databases. And so when you see the syntax of like how they're constructing or creating a store procedure, this is what this is doing. This is creating a store procedure. This is following that PL SQL syntax. And I've worked in organizations where you couldn't make direct queries against the database. You had to use store procedures for everything. And then I worked at other places where they did the exact opposite, where you only used direct SQL queries. But one of the things that's nice about store procedures is that it forces you to parameterize your queries. And one of the common problems that security's had with SQL databases in the past is this idea of SQL injection. And so if you're using store procedures, that helps protect you to some degree against having those types of SQL injection attacks. This is an example of a function. So just like you have procedures, you also have functions you can run as well, very similar syntax. And there's also some extras that we get with Postgres. So Postgres, they have this concept of JSON B documents. And so essentially what they do is you can take a JSON document and it stores it in a binary format in a table. And so it's actually very convenient. They've got great indexing features and stuff that are in this as well, which makes it very easy to kind of search for certain things inside of the database based off of specific properties that you'd have inside of your JSON document. Also PostGIS, which allows you to do location-based search, which is very, very handy if you're working with latitudes and longitudes. So those are some of the extras that come or you can have with Postgres. So with those JSON B functions, if you're trying to do a search for something that has contains, you can do @ and then do your search based off of that. If you also are just trying to return like a specific property or object off of that, you can use I guess it's not a rocket, but that's like a -- And then they also have one that will just return the text of that as well, which is -- you can use the question mark to do check for existence. And they also have functions you can use if you need to do run a function against each different property or each different key inside of JSON documents. So they've got a ton of features and stuff baked into this if you need to be able to work with and do searching on JSON documents inside of Postgres. Question?
Have you worked with any of the transaction, or does it support transactions in Postgres?
So it does support transactions, and it does some really neat things with transactions, which I'm about to get into. So, I just with this slide right here, this is talking about PostGIS. It's also an extension you can run on top of Postgres. It lets you store points on, let's say, a map. You can also store lines and multi-points and stuff like that. So if you're trying to store like a geographical area, as an example, you can do that using this data type. And the way that works is that in this case, let's say you have a geotype here, or geography type that you're using. You basically just have to pass it in like this. So you specify a point, and then this has I believe that's the longitude, and that's the latitude. And then all the calculations are actually done on a spheroid. And so I don't know if people have taken cartography, or I went through the joy of taking a couple of classes in college on navigation systems. And one of the things they teach you is that when you're looking at the Earth, as an example, there aren't any people here that believe the Earth is flat by a chance. Okay, good. So I always grew up, in my house, we had a globe, and the globe was like a perfectly round sphere. And the Earth itself is not a perfectly round sphere. It actually stretches out along the equator because it's spinning around on an axis. And so just the mass of the planet spinning around like that causes the shape of the planet not to be a perfect sphere. So when they are putting points and stuff on the map, they're doing their calculations and stuff like that, it's actually based off the fact that the Earth is actually a spheroid.
Isn't it an oblate spheroid?
No, I think like Mercury is like an oblique spheroid. I could be wrong.
No, oblate. It's
Oblate?
yeah, because it's flattened at the poles, and it's bulging at the equator.
That's okay. In that case, yes.
Omelette, not omelette.
Okay, I got your geometry wrong. I'm sorry, Jody, but yes, that is correct.
So when you do search, can you kind of, what you said, it's called search, right? How can you search? Can you have a multi-line area?
Oh yeah, absolutely, yeah.
And is it fast, or is it?
Yes.
Because they were like pure before this, the pure SQL kind of procedures do the same, that you can load
Yes.
into a database and they will calculate this stuff, but they were like awfully slow, because they will have to calculate all the things on the fly in SQL kind of code, not machine code. Yeah,
so one of the things that I learned when I was in college was that, when I was going through like high school and stuff, we learned like trigonometry as an example. And when you start getting into spheroids, you're dealing with spherical trigonometry. And so if you ever looked at the equations that are used to figure out, the distance and the direction of let's say, a line that goes over a sphere and stuff like that, you have to use spherical trigonometry to do that, and the calculations are a lot more complex. There's some equations that are a little bit more efficient. They're used. I forget what the popular one is, but that's the one that is typically, like, we had like our own version of that we stored as a function inside of SQL Server to be able to do those types of searches. But nowadays, a lot of modern database systems and stuff like that, they have those functions built in to it. And like MongoDB, I don't know if people, I think some people have used Mongo and stuff like that.
Started, they implemented like a long time ago.
Yeah.
That's why a lot of companies moved to Mongo, because it was part of the package.
Oh yeah. So Mongo is actually really good at doing those types. And I built a proof of concept about a year ago that used MongoDB specifically for that reason. But I could have used Postgres and PostGIS to do that as well. So, EJ, I believe you were talking about transactions and stuff like that. This kind of gets into this right now. So, one of the reasons why people are using Timescale, and like I said before, this is a extension that runs on top of Postgres, is that they have all these optimizations they've done around the way that tables are made up and stored inside of Postgres, specifically hybrid tables. And so what they found is that you can get somewhere between 10 to 100% faster than normal Postgres performance with these data sets using these hybrid tables. And the way they're able to do that is they're doing that using something called chunks. And so what they're doing is they're actually taking a table and they're breaking it up into essentially these bite-sized pieces that are based off of time and space. So, and you can also scale up to petabytes in size. This is how scalable this is. So if you want to create one of these tables, the way you do that is you specify a create table statement. You'll need to at least have one time column in there that you can use. And then what you do is when you go to create, there's this function here called create hypertable. And then the first parameter, you just mention the name of the table. And then the second parameter, you just specify the date, and boom, you're done. That's all you have to do to create a hypertable inside of TimescaleDB.
Wait. So what I'm doing is select create hypertable.
Well, the select basically tells you whether or not you're successful or not. So it's just returning back whether or not the function worked correctly. So for instance, if you specify a column that's not a timestamp, you get a failure. But in this case, it would tell us we're successful. And I'll do an example of this here in the demo to show you how it works.
So, okay, the table itself has nothing special other than having a time.
That's correct. That's correct. That's the one prerequisite. Your table does need to have a timestamp in it. All right. So with that,
Go in a certain order, addresses and the parameters just have to be personal.
no, it doesn't. No, it can be anywhere in the table. So with Node.js and Postgres, if you're going to be working with Postgres, there is a NPM module you use. It's just called PG. It's probably one of the original or one of the first NPM packages. It's been around for a long time. You can just do an npm I pg -- save, and that will install the module into your project. And one suggestion I have about I've used Postgres a little bit over the years, and one of the things I found is that there's a couple different ways you can connect and make queries with it. If you're going to have a continuously running application, for example, you definitely want to use pools when you do that. And so pools is one of the ways that you can connect and run queries and stuff against Postgres, but I found that pools are the best way to go. You also can use clients, but those are a little bit harder to manage, but my recommendation is just to use pools. So this is an example of a very simple Node application, and this is one I used in a previous presentation where I was taking a bunch of different stocks and trying to feed them into a stock table. And so what I'm doing here is I'm actually using the newer import syntax here. And so I'm just importing the PG module in from the PG NPM package here. And then I'm grabbing the pool off of that. Once I have the pool, you can actually set these values up as environment variables and just say new pool, and it'll create this. But here I actually have it hard coded into my example. Don't do that. And then the other thing that I'm doing here is I'm using the promise, some of the file service promises to actually read back a CSV file or grab the data from a CSV file. And then I'm just taking each record or each row in that CSV file, grabbing these different parameters and just inserting it in using this insert query, which I neglected to put into my example. And then once I'm done, you can see here I'm using a wait on my pool.query. That's because this is a promise. And so by using a sync and await, what I'm doing here is I can use this like a regular, procedural type of code. And once I'm done, I call pull.end to basically close the pool. So that's basically all you have to do if you want to. In this case, I'm writing a bunch of stuff to a table that stores stock information. So let's do a quick demo here and see how this stuff actually works. So everybody can still see my screen. And what I'm going to do is I'm going to run this example in Docker. Probably the easiest way to to get this up and running locally is if you have Docker installed on your system, it's very easy to spin this up using Docker. And I have a blog post, which I'll put a link to in here, that describes what you have to do in order to get this installed and running under Docker. But if you're not familiar with Docker, Docker lets you essentially run application containers inside of kind of like a Linux VM on your local machine. So if you're running Windows, you're running a Mac, but you need to be able to run your application on the same, hopefully everybody's using Linux as an application server, you can essentially run under the same environment that you deploy to. So it's very handy for that. So I'm gonna run Docker PS, which will tell me if I have any running containers right now. Right now I don't have any running containers, but I can check to see if I have any that I have stored here. So I can do that by doing Docker PS-A. And this shows me all the different Docker containers that I have named here. I might be able to run. I'm not going to search through all those. I happen to know which one I want to use. I want to use the one I set up earlier today for this. So I'm going to say Docker start. And then the name of my container is temp-timescaledb. And that should have started up. So I'm going to test that, make sure that that's actually working by coming here and saying table plus. And let's see if I've got that running here. All right, so let's take a look here. I've got the stock table here. And voila, it's pulling back a bunch of stocks here. And I can test this out here. I come over here to my SQL. And let's say I want to test out the stock table. I can come over here and I can say select star from stock. And let's actually put a limit on there. I want to return back 10 records. Now I can highlight that, run. And this should have just returned 10 records here.
So David,
yes.
I think you missed telling us some fundamental information about timescale.
Ah, okay.
Is it a series of snapshots in time? Is that what it is?
So basically the way it works, I wasn't sure if I had a slide in this. I have another blog post I did that explains exactly how hypertables work, but essentially each chunk basically is a table, right? So think of each chunk as basically as a child table. And then the hypertable itself is like a parent table, which is just made up of all of these different chunks. And what they do is for each child table, it corresponds to a range of time. So maybe it's 6 hours, maybe it's 2 days, maybe it's a week or whatever. Each one of these different tables basically corresponds to a period of time. And one of the things that's really nice about that is, let's say you are working with highly transactional data, and say after 6 months or whatever, you know, I don't need anything older than 6 months. I've got that stuff backed up somewhere or whatever. I just I don't need to pay for, you know, that disk space and stuff like that. So I know that, okay, I need to get rid of the last 2 days of my 6 months worth of data and stuff like that. When you actually go and delete that from your TimescaleDB instance, what it'll do is it actually will remove the whole table. It drops the whole table and the file associated with it. So one of the typical problems, like if you're trying to purge, let's say a database table, let's say you have a database table that has like, I don't know, 60 million records or whatever. One of the problems you have is if you delete, let's say maybe 40% of that, stuff like that, there's all kinds of defragging and re-indexing and stuff like that. There's maintenance that goes along with having to do that.
And much better than MySQL, where any amount of deletion will not reduce disk usage.
Yeah.
The only way to shrink a database is to drop it.
So anyways, that's one thing that's really nice about TimescaleDB is that it's a lot more efficient at doing stuff like that. So if you are working with highly transactional data where you do need to delete like a set of it at, due to time, you can set that up so it's all automated and stuff like that. So it's really nice.
So let me see if I understand. TimescaleDB is basically take a table, and instead of being a point in time snapshot of that table, it is a range of time snapshot. So, everything from, you could slice it up by day, let's say.
Yeah.
So everything happened on a certain day is in that table, and you can drop it.
Exactly. Exactly.
And hypertable is a super table that joins them together. If you wanted to query across all time ranges, then you would go to the hypertable.
Exactly. Yeah.
But you never actually go down to the level of a single table, right? You always query the hypertable, right? The internal table, this individual table is never.
To the developer, the end user, it just looks like a single table. So let me show you an example of what this actually looks like. So I have one here that I already had highlighted here before. So I have this one.
Can you also have constraints on the table in case?
Yes. You can, like I said, you can treat it just like a regular table. So when you're designing the table.
Keep the performance down. If you want to drop the table, you still have to go and make sure that each record, within the constraint you have. Like,
Yeah, yeah. So I mean, you're not gonna be able to get rid of those types. Like if you have a constraint, so like if you, in other words, like you can enforce referential integrity and stuff like that inside your tables, just like you would any other table. And then same rules apply there that would apply to any relational database.
It just gives you horizontal scaling using that time range as a partition key in a sense.
That's
sharding
right.
key.
Yes. And you can even set it up so that it also scales out over like a specific, like for instance, if you do let's say your primary key is made up of the timestamp and say like a device ID. So let's say you have a IoT monitoring application as an example, and you have all these different devices and stuff like that that all have their unique ID. You can set it up so that when you are writing all this data, all this time series data out into the hypertable, it actually will create chunks specific for, let's say, a device ID, as an example. And so you can have it spread out that way. And so when we looked at the earlier slide right here.
So in addition to DT, you could say device ID.
So typically, like if I'm just specifying like a date column as an example, then what this will do is this, your chunks and stuff will just basically go vertically.
Can you go back to that create hypertable slide where you had the SQL DDL? Yeah. This one, yeah. So basically, in addition to DT, you'll have other keys to go with it. CT comma something else.
So is it kind of like to a certain extent that it's creating little buckets based on timestamp?
Yes.
Okay. Yeah.
That's easy. That's a good way of thinking of it. Yeah.
But shards, you could call it shards.
But the buckets can be based on something other than time as well?
Yeah, I think you were saying, so where you had the create hypertable on mention comma DT, you could have mention comma DT comma other things.
I believe so. I have to look at the parameter or the way that you specify parameters for that function. But in this example, I just have the date time. So if I come over here and I run this,
I think that's what he was saying when he was saying about device ID. That's
yeah. So here I just created a table called account transactions. So I'm trying to store all the transactions for different users that are coming in. And now I've done that, I'm gonna come over here and I'm gonna turn that into a hypertable. And voila, that's done. So now I've got my hypertable. And what I went ahead and did, let me blow this up so it's a little bit easier to read. I've just created some dummy data here that we can go to insert into that table here. And so here I have a insert that I'm going to be doing into this account transaction table, where I'm going to be specifying a different user, date, time, amount, and source. And let's see if I can't run this real quick. Well, you can create a view that's based off of a hypertable. And if you're doing like a materialized view, as an example, you could also, I'm sure there's performance advantages and stuff you can do with that as well. But the whole point of being able to do the hypertables is to make your querying super fast. So you're supposed to be somewhere between 10 to 100% improvement in your query performance.
Is that because it's chunking up the tables?
Yeah. They've done all kinds of things to optimize the query plan inside of Postgres. So apparently, that's one of the things that's nice about Postgres is if you're trying to write extensions for the database, they have a very good model for doing that. Like
the PL, like you were saying, language PL, PGP and SQL. Similarly, they support JavaScript, Python, BCL, Java itself, and a few others.
Oops, count. Let me refresh this.
So you showed us how we insert into a hypertable, how we were chunking the data. So you would say, I would chunk all of this based off of this stage, right? Or this stage. Like, have you showed that yet? Or?
Well, so they do it automatically. So when you go and create a hypertable, as an example, the system is going, or timescale is actually going to do they have an internal algorithm they use that, judging by the amount of data that you're inserting into the table over a given period of time, of like where it needs to start chunking out those pieces and stuff like that. And so one of the goals that they've had is they've tried to set it up so that whoever is using, there's very little they have to do as far as configuration stuff. There's a lot of control that you can go in there and do. Like if you need to be able to have that type of fine-grained control, my understanding is that you can go in there and set that up, especially like, for instance, like if you need to set up like, okay, I need to get rid of anything older than 3 months old and stuff like that. It's all stuff that's
like MongoDB, I think it's like a key that allows you to say time to live key, I think is like what it was, where you needed that. So
yes.
The system manages that.
Yeah.
Okay. But how do you also specify, hey, this DT, this account ID is also something you would be storing based on? Or is that also managed by the internal editor as well?
Well, in this case, we actually specified the column that we're using. That's the date time column. So for
but like if you want to say date time by and account, like you were saying, if we had the things identifier. So like you specify that it also is going to be stored underneath ID and date time, or is it just going to handle that for you when it realizes that there's a lot of unique or replicated data? Or? So
as far as like specifying, like for instance, like that's something you have to set, whether or not you set that up in that create hypertable function, or you just do it with the primary key.
Yeah.
Yeah. So one of the things I did with this table, I believe, is I have a primary key that I set up here, and the primary key is actually a combination of that date time and the user ID.
Yeah. Gotcha. That makes sense.
All right.
Can you create indexes on the hypertable?
You can create indexes on the table, and then those indexes and stuff are going to be maintained at the chunk level. So that's one of the reasons why they're able to get the performance and stuff, is because when, for instance, like when you're creating like a primary key, that's an index on the table and stuff like that, and that's usually kept in line in the table. But if you're creating like separate indexes and stuff like that, those will also be maintained for each chunk in the table.
Is it possible to query?
Yeah, go ahead. No, I mean like so you cannot create the indexes on the hypertable, but on the chunks we can create. That's what I mean. Right?
Well, whatever you have on chunk, transfer to the hypertable.
Okay.
Yeah.
It brings up a question then. So if you, let's say you really have a huge time series, it will create a bunch of chunks behind the scene, right? The purpose of the index is it would be in some way sorted for the fast search, but now if you have indexes separately for each chunk, would it, how would that kind of glue together?
That's a really good question, and I'll try to get an answer to that. I saw a presentation that one of the architects of TimescaleDB did, where he was explaining some of the internals and how they work with Postgres. You know, indexes, the science behind behind indexes and their B trees and how they work and stuff like that. There's a lot of stuff that typically it's difficult to do when you're working with like very large tables, where you have fill factors and things like that, where you try to say, well, I know that this is going to be something that's going to be updated, or we're going to be inserting records in this database fairly frequently. They're going to be in different positions or different parts of that index and stuff like that, and that's very difficult to scale. But my understanding is that the indexes get tied to the chunks. So as far as like how they're able to optimize that, I'm not exactly sure how they're doing it. Yeah.
Is it possible to query the table such that that does not include the time dimension? So meaning to say, let's say an aggregate query, sum of any column, right? But that's across that irrespective of time, nowhere clause for time.
So that's a good question. They definitely have some stuff they've done specifically around aggregates and doing aggregates, and that's one of the things that it's supposed to excel at. So
and go across those, because time is not a dimension, therefore it has to go across all chunks. And then, doing
Probably
averages.
performance is a regular table design.
Why would you want to run, aggregate across a table like that?
So you say your chunks are by day, and you want to find the average price of the stock across the month or year.
Okay.
So now you're spanning across chunks.
So they have specific stuff they've built into the timescale for doing aggregates.
But I guess you can rewrite that, whatever the aggregating function logic is, just to work with this chunk, like kind of spanning tree. It will go process chunks and then come back.
Right, I'm sure
You're looking for maximum, right? It's going to go find the maximum on the chunks and bring it up and find the maximum on those and stuff.
I'm not reduced. Yeah, that's what you should do. In fact, you should do it in Packer.
Probably that's what they would do.
Yeah, you could even possibly just tie it into a stored procedure, just to make the information.
But these are native functions that I'm talking about, like average being native function. So my assumption is that they have some backend optimization which basically splits that average into a map reducer.
I guess if it's not worse than just having a huge table in performance, then you're still kind of winning on all other cases.
So I think this piece right over here answers your question about the aggregates.
Can you command plus and
I'm sorry.
Yeah. What is that?
This is called continuous aggregates. This is the stuff I was talking about that's baked in for doing this type of stuff. So you can create materialized views around basically being able to do that. You can see also they have functions in here for setting up aggregate policies as well. So yeah, that's one of the things that's specifically built in, because that's a common use case when you're working with that. I want to find out what was the average price for the stock in this month, that kind of thing. All right. So I have yes, go ahead.
Hey, I have a question. Is there any compression available in Postgres, and how does it compare as far as speed is concerned with MySQL?
So it's supposed to be really fast. They do have compression built into it. I don't know the specifics about the compression, but the answer is yes.
Yeah, I think anybody who has used MySQL extensively, they will find Postgres a pleasure to use at every level.
So when I first started working with PHP, one of the things I was told was that it's like, well, people typically use PHP with MySQL, but Postgres is way better. It's like I always heard from people.
In fact, now that I know about Postgres, I'm thinking, like, how did we end up using MySQL as the default for all the time? Like everybody,
Postgres was crappy.
The M
time ago, it was way worse.
The M in LAMP stands for MySQL, right?
Yeah.
But
I don't think it was open source, right? At some point.
Postgres was always open source.
It's been open source at least since 1995.
Since it was like, I remember like way back, we used Postgres and it was something like really weird about it.
MySQL used to be a proprietary product, by the way.
The other way around.
And MySQL used to be proprietary. And then they went open source at some point.
Yeah. So when I first started using MySQL, this is an example. Like there was no stored procedures. I mean, it was to me, it was a very simple database compared to.
It didn't have something specific like.
I think it was MySQL 5 where they added stored procedures and yeah. So I mean.
Oh yeah, it used to be MyISAM.
Yeah.
At one point, and then they went to the other one. What's that called?
So I'm not sure, but I know in my career, it's like I didn't start using Postgres until recently. When I say recently, like in the last 5 years. And the reason why I started to was one of the companies that my company works with, one of our partners is Salesforce. And Salesforce owns a company that does hosting called Heroku. And so, for instance, like if you want to set up a database to work with your Heroku container, they do that with a Postgres database. So the database that I got for free was a Postgres database. So I was like, well, I'm going to learn how to use Postgres because I get this for free when I use Heroku. So that's how I started using and learning anything about. But I always heard it's like, oh yeah, MySQL is very popular and stuff like that, but Postgres is better. But I never ran into anybody or talked to anybody who actually used Postgres and stuff like that. And so
Yeah.
I've been using it now for about 5 years, just for personal projects and stuff like that. And so to me, if I've only been using something for 5 years, that's new. So
Yeah. No, Postgres has been, yeah. Like, yeah, to be honest, I myself don't know why I was using MySQL all this time.
yeah. Well, anyways, I've done a series of blog posts specifically on using Postgres and timescale with Node. Those are available on my blog. They're also up on Medium as well. Does anybody here have like a Medium account? Okay, good. You should go to Medium and look them up there because Medium typically is behind a paywall. And if you go and view and read my posts and stuff on Medium, I get paid like a cent or something like that. But if you don't have a Medium account or whatever, you just want to read them for free, you can do that on my blog. It's the same article on my blog that I put on the Medium as well. Also, Postgres and Timescale, both of their websites, they have excellent documentation on these features and stuff and how to use them as well. So those are good resources to use as well. And with that, are there any more questions?
One thing I do, not a question, but a comment here is that everybody should, if you like Postgres, you should definitely check out Hasura. Hasura is nice, very nice.
Is that a tool you use to query it, or?
Hasura adds a GraphQL layer on top of Postgres. It'll like just you add Hasura to it, and then it will retrospectively introspect your Postgres database and suddenly create GraphQL objects. Now you can query through GraphQL. Not only that, that's just a part of it. More importantly, it will it allows you to do real-time watching of like subscriptions, GraphQL subscriptions. So you can get a WebSocket, callback.
So it's technically GraphQL server.
Yeah, it's a GraphQL server layer on top of Postgres, but it's more than that. It's much more than that. In fact,
so which language is it in? If you have to do like custom resolvers, would it allow you to write it, or just whatever the database?
It does allow a custom resolver. I'm trying to remember what language. I think it's Node.js, but don't quote me on that. I think it's
interesting.
The most popular using Apollo.
Yeah. By the way, speaking of which, I don't understand why do we use Apollo? because I do all my GraphQL querying without any library. I just use fetch. So maybe I don't know. I'm still trying to figure out why we have to.
I've never used GraphQL in a production environment. I've only used it in playgrounds and like.
But you need a server, Apollo server, right?
Yes, server you do. I agree. But on the client side, that Apollo client, I never understood.
The React client's really cuts out.
No, I mean fetch. I do fetch. I say fetch.
What about you linking your you know this caching on the browser side, like all that, like okay, you can reinvent the wheel and write it all, but we can just do npm install and you all of a sudden have it.
I mean, you almost never want old data, do you? I mean, I don't.
But that's what I'm saying. Like with React, I was doing some good series of like the guy was reinventing the Slack from scratch using Postgres, Node.js, and GraphQL. Like it's easy to find like a really good, like kind of short videos, but he does it all. It's kind of dated, but still. So, and that's what you have out of the box with a client in the browser. You don't really, with React, it integrates in a way, you don't even have to worry about. If you subscribe to something, the event is going to come into your client, it's going to go kick out, you know,
yes,
your
the only time
date, and it's all of a sudden.
The only time I would use Apollo client is if I have a subscription, subscription. Yes, then I would use it. But otherwise,
when you save, they do this kind of, I don't know what it's called, not lazy,
Yeah,
but you can save.
I know.
Hold on a second.
Like
optimistic save.
yes.
So it will go populate your data, and then later on, once a reply comes from the server, behind the scene, it's gonna go and switch it to the actual, like, populate the ID that came back from the server and things like that. And you don't even need to see this. It's kind of somehow like a magic behind the scene.
I mean, I agree. I'm just saying. Well, there's one more thing, by the way, about GraphQL. You should know that there is such a thing as persistent queries. What that means is, you know how even the read operation in GraphQL is a post. Doesn't need to be. In fact, posts are supposed to be updates. You should not be doing posts. You should be doing a get.
Hey David, I gotta go, but thank you so much for your presentation.
Oh, thanks, Jody. Thanks for coming.
Sorry,
Bye.
we veered off into the GraphQL topic. I was just saying that if you use persistent queries are basically you have a big old chunk of GraphQL and you compile it through this persistent query compiler and you save it on the server, and now it gives you a hash ID of that query. And now you can use a GET request with just that query ID equal to that. And now you can retrieve it, and it really becomes a GET, which means you can cache it. I mean, the proxy server can cache it, and so on and so forth. Another advantage of that is you can control what queries you allow.
Well, isn't the whole point of GraphQL allow your consumers to be able to ask for whatever they want in whatever manner they want, you know? And also, like, the fact that it is a post versus a get, like, having RESTful paradigms inside of GraphQL is like, kind of like, they're two totally different paradigms, so judging one over the other. But if it does cache it with your proxy server, then that makes sense too. So
Yeah.
first
Yeah,
is everything.
Sometimes you don't trust your client. Let's say, for example, this is a public website, right? Now, nobody's actually logged in, so you cannot trust what the visitor.
What Bobby Sue's going to be asking for. She might ask for all social security numbers.
Yeah, not just, okay, social security number you have hidden, but you don't want to give more than 50 at a time, let's say 50 articles at a time.
Yeah.
And Bobby Sue is asking for all 50,000 of them, and that'll just crash your server.
Yeah. Oh.
Sorry, back to
No.
Postgres.
I was basically that was something I didn't know, but it seems like you pretty much when I had that slide before of Golem, one database to rule them all. That's another example of why Postgres is the one database to rule them all. So
did you use a JSON kind of feature there? I know they announced it a long time ago that you can pretty much make queries like with JSON payloads supporting the JSON.
Yes.
yeah, they have specific functions that you can. Basically, there's like a shorthand that you can use in your queries to pull back, specific documents or specific, properties and stuff off of those. If you need to pull back a whole JSON object or whatever off of a single property, you can do that. Or you need to read text off of a specific field, you can do that as well.
Postgres allows where clause with querying the JSON, not just the whole JSON chunk, but a specific, you can traverse the tree, the JSON tree, and say if // this is equal to y.
But is it actually usable or is it just like really slow?
Yeah, I have done performance check, but
In our mobile apps, we're using a SQLite database where we're storing JSON documents essentially as a document inside of each row. And we're able to get pretty efficient queries back from that and do that. So if you can do it with MySQL, but if you can do it, with SQLite, you got to be able to do it.
No, but to answer your question, no. I don't see any way it can be efficient without proper indexing. So it's got to be otherwise.
Yes, they have full-on indexing you can do with JSON B documents in Postgres.
Yeah, as long as you have indexing.
I believe Microsoft SQL Server does the same thing too. You can index specific properties and stuff inside of JSON documents, stuff like
My
that.
experience, JSON in Microsoft SQL Server is pretty tough to do.
Yeah.
As seamless as what it sounds like.
You can parse the JSON kind of like you store it as a blob. You can within your query you can blob parse it and then go and traverse like the tree there. But it's kind of
If you ever want to have real fun, try working with XML documents inside of Microsoft SQL Server.
So is there any enterprise level companies that you know that's using Timescale?
Yeah, actually, let's take a look at their website. It's the thing that's interesting about when you list companies and stuff. A lot of times it's like, some of them will say, oh, please don't mention us and stuff like that. But you have to get permission before you can do that. They do shipping, so they have to keep track of containers and stuff like that. So that's a perfect example of something that Timescale would be good at. Cisco, IBM, Comcast, Walmart, DigitalOcean.
Which one is that?
Walmart?
I
think they're trying to compete with Amazon. I'm not sure about that.
They have, if any brick and mortar store has the capability to, I actually worked with somebody who's a PM over there, and they were pretty aggressive in trying to expand their electronic presence.
Yeah. So one of the guys, the guy behind, I'm blanking on his name, the guy behind Hoppy, which is one of the more popular Node.js web frameworks, he developed that at Walmart. Walmart was, they're developing their e-commerce presence and stuff like that. And he was like one of the early Node guys. And, they developed that framework, I believe, out of Walmart. And so there's a number of interesting technologies that have actually come out of Walmart. There's electronic document format that's been around for forever that was developed out of Walmart. It's used for medical document. Yeah, so Walmart's actually, that's actually one of the reasons why they were able to grow to the size they were. It's because they were early on adopters of information technology. Yeah.
Oh, really?
Yeah.
Compared to Amazon, I thought stodgy or low tech.
Think about it. They're essentially doing the same thing that Amazon. From a e-commerce point of view, they're doing the same thing that Amazon's doing, which is they're trying to get the product as low as cost as they can, distributed exactly where they need to be for their customers.
Yeah, but if you go to Walmart, I really want Amazon to die. Okay. but I try to give my business to Walmart, but
Well, that's the thing. It's like they were doing something I think was really kind of despicable. Was Walmart, that is. They were going around to the different vendors and stuff like that, and they were telling their vendors and stuff like that they couldn't use AWS for their IT hosting. And if you want to be a vendor with us, you can't use AWS. And it was like, well, do you offer, cloud hosting and stuff like that? It's like, last time I checked, Walmart doesn't offer cloud hosting and stuff like that. It's one thing, like, so if you had your own alternatives, like, hey, you want to be a vendor with us? We want you to use our cloud hosting. They don't have a cloud hosting service, so it's like, okay, so I guess you're telling them to use Microsoft or Google or something?
Walmart, basically, they're going to be looking those news to see if they start acquiring the cloud storage company.
Yeah. Walmart acquired Jet.com, if you remember.
Yes, right.
Jet.com. And where is Jet.com?
No, but they acquired it for the online sales kind of.
Yeah, but, I mean, not for the brand. Yeah, true, but I did not notice any special improvement in Walmart's online presence since then. I've been watching. I still do order stuff from Walmart.com when it's cheaper or the only place available, Amazon doesn't have it.
I think somehow after that happened, that whenever you search for products online, Walmart will pop up on top somewhere, so you would see more. But then once you land on the Walmart site, it's a mess.
I actually
don't want to find there.
I'm not really sure how this happened, but like during this past year, I ordered something on Amazon, and the order, however it went through, it wound up coming through and being shipped to me through Walmart. So I got a product that had a Walmart sticker.
Sellers.
Yeah. So I'm not really sure how that happened, but it did happen. I was like, that's weird. It's like, got something from Walmart from an order I placed on Amazon. So yeah, it was interesting. So yeah, so Walmart did some pretty interesting things during this past year. Like they set it up like, like early on when everybody was afraid to like go into any kind of public place and stuff like that, they set it up to where you could pull up and they had their mobile app or you let them know you're there and they would come out and bring your stuff. Yeah, just deliver it right out to your car. You didn't have to go into the store. My understanding is that they did away with that. They're not doing that anymore. But I mean, that was something they're still doing that?
There's a hack. If you want something like cheap for free from Walmart, order online.
Remember, this is being recorded.
They deliver. It's fine. They deliver. Then you say like, oh, it's something wrong. I want to return it. And we had like several items like under $5 or something. They just say like, okay, we return the money, keep it.
They just write it off. Yeah.
You just keep the item.
No, Amazon does that too. Sometimes, like when you want to don't want the item, you put the return request. They said, okay, you don't have to return. You take it. We'll take your money.
Or you go to the self-checkout line and then walk out with it.
All right. Well, I think I'm going to end the online portion of the meeting. Thanks everybody for coming out. And we'll have something hopefully neat, really planned for next month as well. Have a nice evening.
Hey, you too, buddy.
All right.
So, there's something